Okay guys, welcome back. So today I have a power supply board out of a Samsung LCD TV, 55 inch, right? And we'll go to the part number. This is how you get someone to actually ask me about getting part numbers off Samsung boards, where you find them, and how do you read the sticker. It's very easy. Any Samsung power supply board, you just go to the barcode sticker, with the barcode, and you start off with the BN number. So this is going to be a BN 44-00268A. Okay, you stop right there and you begin right here at the BN number. All right, and there's a dash between the 44 and the 00. And this Samsung board is used in two different TVs. The first one being the LN55B650T1 and LN55B640R3. 55 inch Samsungs, and as you can see, it's an older LCD TV because it has the two transformers for the inverter boards. Okay, so it uses the CCFL lamps, and the TV was probably manufactured in anytime between, I don't know, I'm gonna say 2010 to 2013. I'm not exactly sure. I have the TV here, but this board, or the TV, actually has a symptom of being a dead set. All right, which means there's no standby light when you plug it in. Of course, there's no picture, no clicking, no sound, nothing on the screen. It is as if the TV was unplugged from the wall. Okay, that's a dead set. No light, no nothing, just totally dead. All right, and a lot of technicians. So I want to just get this straight, right? A lot of technicians think that, or even people, consumers, if the TV is dead, it's the power supply board. No, that's not true. The next time I'm in the shop and the technician tells me, oh, I didn't have to take the TV apart because it's dead, so I just ordered the power supply repair kit or the power supply board because it's dead, I'm gonna slap the out of them, okay? It's a very easy way to determine if a dead TV set is either the power supply board or the main board. All right, you go to this plug here. Always go to the plug where the standby voltage is. The plug is going from the power supply board to the main board, and you check for a standby voltage. If you don't have any standby voltage on here, okay, on that plug where it says, most likely it's labeled on the board, standby SCB, 5 volts, 3.3 volts, whatever you use this, 8 volts, 12 volts. On some Samsungs, if you don't have it, just unplug it from the main board. Make sure the main board is not loaded down or whatever. That means that you have a bad power supply board, okay? If you do have standby there on a dead set, most likely your problem is the main board, all right? Real easy. We're going to check the AC fuse, okay? So I'm just giving you a little rundown of how basically all power supply boards work. Okay, right here, all right? So, all right, now I did a video on, I don't know, maybe like a few months ago, back in October, on switch mode power supply boards that's used in TVs or any other various devices. Any switch mode power supply is all pretty much the same. Okay, so we have line in, cord, AC, have our fuse, all right? Let's just come zoom out a little bit. All right, so we have our fuse. All right, our fuse, our MOV, right? Or what is that? Mineral oxide varistor, right here. Okay, see this in green, right here, and that's to protect the neutral and the other line, right? Okay, then we have our EMI filter, which most likely includes capacitor, inductor, right here. Capacitor, inductor. Okay, then we get through there. Okay, we're gonna go through our NTC, all right, which is also a mode of protection, right, overcurrent protection, which is right here. And then after that, you may have a fuse also, and there's going to be, I'm sorry, will the fuse come before them or after? I think the fuse is after them. We're going to have a rectifier, okay, rectifier diode, and as you can see on this one, it's located right here, and that converts your AC into DC. All right, and then we go to our capacitors right here, and then after that, it is then going to the switching transformer, okay, via being switched by a FET, okay, or whatever it uses. So, we're just going to go step by step on this board. So the first thing we're going to do is check our AC fuse. All right, so there should be AC fuse right here. That is good, all right? And if you see another fuse, you can always check that also. I see another fuse right here. This is for the DC circuit, evidently. So we'll check that. That is also good, all right? So next, we want to check for standby voltage on our plug going to the main board, all right? Now, this should be labeled, I don't know, there it is, SB, all right? So that would be pin number 3, it looks like. Right here. Come on. Pin number 3. All right, 1, 3. Okay, 5, 7 like this. And second row is pin 2. 2 is the even numbers. Pin is 2. Ground is pin 4. Pin 6 is ground. Pin 8 is 18 volts. Okay, that's that power supply on. PS on. Okay, that's the voltage when the main board is turning on the power supply and it's going to activate the rest of these voltages. But for right now, even when the TV is just plugged in, it's not powered on, we should have the standby voltage, which is pin 2. Okay, so I'm just going to go to the bottom. All right. Go to the bottom. Pin 2 should be from the top one. Okay, so I'm going to do, all right, I don't have my TV plugged in. I just got the power cord plugged in, but it's not plugged into the outlet. So I want to turn it around and show you guys. Well, I'm actually going to ground my meter, okay? And this is going to be checking the 5-volt standby on the cold side right here. I'm going to use, as you can see, this is separated hot, cold. I'll turn it around so you can see it better. All right, anything on this side of the black where the power cord is, that's hot. And this is cold, okay, right here. And as you can see, this is where our plug is going to our main board with our standby voltage on. I think I do got it marked. But I'm actually going to ground my meter right here on any one of these on the secondary side, the cold side. These metal things here. They're going to cut off on me now, okay? If I want to verify, I can just go to one of the pins that's reading ground. Should be, let's see. Okay. All right. So that is ground. I'm gonna put my meter in DC volts. All right. So, and I want to check our standby voltage. I'm gonna turn it around. Okay. I just want to plug it in. All right, meter's in DC volts. I'm gonna go to this pin right here. And I have 0 standby, 0 voltage. All right, now in the TV that you can't see, when it's unmarked and you can't see the markings, and you're checking for standby but you don't know which pin it is, just check all the pins at DC volts. Okay, if you get any voltage that comes up that's 5 volts or 3.3 volts or whatever, then most likely you have standby. But you just check various numbers of pins here. Nothing there, nothing there. And the reason I'm checking it from the bottom is because I don't want to short the pins out, you know, with my leads, my meter leads, so it's easy to go this way. Or you can just unplug the plug that's going to the main board and leave it connected to the power supply board and check it on the other end of the plug. All right, in the little sockets, the little holes. But there's absolutely no voltage on neither one of these connections, okay? All right, so now I want to check for me, unplug it, okay? And be very careful when you handle these power supply boards and you're applying voltage to it to check it, because you will get shocked, especially on the hot side or primary side of the board, okay? So what I'm gonna do now is unplug this. I'm gonna check voltage across my filter capacitor, okay? And I'm just gonna leave this negative plugged in. I'm gonna put my negative lead on any hot part of the negative part of the hot ground, and we'll go to the negative side of the filter capacitor, right? And I'm going to see if I got the voltage going across there, right? So let me go ahead and plug it in. Meter's still at DC volts. All right, I'm going to see if I got the voltage going across the capacitor. Here we go. 162 volts. Okay, DC. Right. So we got voltage going across there. All right, 162 volts DC. Okay. All right, I'm gonna unplug it right fast. Oh, I see a fuse there, DC fuse. Let me check what's going across there. Okay. DC fuse right here. Same thing. All right. But quite obviously, there's nothing on our cold side, our secondary side. And let me just see here. And be very careful when you're picking this up, because these capacitors still have a charge on them, and you don't want to short anything out. Even when the TV is unplugged, that voltage can still short something out if you rub it the wrong way, right? So our secondary side should be the middle pin. All right. Absolutely nothing. Okay. All right. Okay, now this is where we get to the part that's the problem with most of these power supply boards, okay? And you always have to look for the thing that's under the most stress, all right? For example, switch mode power supply. What's its function? The function is it uses a switching transformer, which is right here, okay? As you can see, this is the primary side, secondary side is isolated, so this is all cold ground, this is all hot ground. Same side as the AC circuit, AC plug, rectifier circuit, DC filter capacitor, right? Big filter capacitor or capacitors. This one uses 2 capacitors. All right. And this will be, so identify the switching transformer, okay? So the switching transformer is all going to be isolated. So one side is going to be on hot ground. The other side of the transformer is going to be on the cold side or secondary, cold ground, right? Right here, transformer right here. As you can see, it's between here and here. All right, this is our line that is separating hot side from cold side. All right. Obviously, like I said, this is the transformers for the inverter boards. So this is a 55-inch TV, so it may use 2 inverter boards, one on the left side, one on the right side. It's like the CCFL lamps. This is not a traditional LED backlit set. It uses the CCFL lamps. All right. And these transformers here, I think I saw some more. These obviously, which are inductors, but they look like transformers, are obviously for the power factor correction circuit. Okay, so what's an 80% of power supply board failures is either going to be the transistors or FETs that are switching these transformers, or the power factor correction circuit, or most likely the main transformers. Okay, so we have to find out what is switching that, because that's obviously the first things that are going to fail on the power supply boards. Now, easily I can just follow the traces on the hot side, okay, because it's driven by something on the primary side, okay, so it can actually produce voltages on the secondary side, right? And so let me see if I can follow anything. Let me see. This is the primary side on this side of the transformer. Am I right? No. This side of the transformer. All right, so I'm gonna follow these pins here, okay? Now, one of these pins should be connected to ground, right? So I'm gonna unplug. Let me go ahead and go to function. without beeping. And my negative side of the capacitor, which is connected to ground, should be going to one of these pins. Let's see. Alright, so this is our ground, looks like. Alright, so the positive side should be going to a FET or some sort of device that's switching this. It's going here. So it's our positive side. It's going from here. Just one winding, right? Going from here to there. It's like a jumper cable. So let's see. Okay, going down here, the capacitor, going right here. Okay. So what is that? So let me zoom in on that right fast. So like I was saying, you want to check. This is our switch mode transformer. You want to check the FET that's driving it. And also you want to check our power factor correction circuit, which I actually covered in the other video. So you definitely need to watch that video. I'll leave the link in the cards on the top right hand corner where you see that exclamation point. Just click on that. But anyway, or either the FET that's driving this here. But the first thing I'm going to check is the FET that's driving the switch mode, the main switching transformer, right? Or what they call the chopper circuit. All right, so we're gonna check the chopper transformer, chopper FET, right? And the IC, of course. But this one uses looks like a 5 or 6 pin IC. I just want to zoom in on you right here. Okay, right there. So the positive pins on that switch mode transformer are going to that FET, so it's being driven by that FET or slash IC. It looks like we got 1, 2, 3, 4, 5, 6 pins. All right, so I did look up the part number on that just so I can get a pinout or a data sheet on it, and this is what I came up with actually. If I can find it, is right here. Okay. This is the part number of that IC. This is a ICE, or just on the actual IC, it just says 3BR1065. Okay, and it doesn't tell me what it is. It's just a current sensing driver, I believe that's what they called it. It's not on this page. But yes, that is driving. As you can see, these are the pinouts. Pin number 1 is the drain. Number 2, current sense. BA3, blinking and auto restart, okay. VCC, all right, it's the supply voltage that it needs to actually start working. And 5 is ground and 6 is the feedback. So this one has the actual FET, right? Okay, and also the PWM or post with I'm trying to say the PWM or the driver IC built into this one IC. All right, so what I want to do is I want to check the ground, which is pin 5, and any of the other pins. Any of those other pins should not be shorted to ground, especially where it says VCC or drain. All right, so ground is pin 5, and pin 4 is VCC, drain is pin 1. So let me see if I can find pin 5. So pin 5. That is grounded. All right, now let me see if I hold it on pin 5. I'm getting 31 ohms. So let's do it this way. I'm gonna leave my meter on the negative side of this filter capacitor, which is hot ground. And once again, pin 5 is ground. Pin 6, I'm getting 32 ohms. Okay, pin 6 is the feedback, okay. And the pin next to it is pin 4. Between pin 4, which is VCC, is grounded. That's out of the question. All right, that doesn't make any sense. And hold on, pin 3, which is BA restart pin. Okay, that's too many. That's 3.8 volts, 3.8 ohms. That's way too low, my brother. Okay, pin 1. which is the drain, is okay. And pin 2 is reading 0.1 ohm. And pin 2 is current sense. And that's all saying it's shorted to ground. So we got every pin shorted to ground except for the drain. So that is very weird. So what I'm gonna do is pull that out, recheck the traces, and make sure they're not shorted, and then I'll replace that IC. I do have one, I believe, and see what happens. Okay, pin 5, that's the ground. They're shorted. Yep. $31 ohms. So ground and pin 4, which is the VCC, straight short, 2.7 ohms. The next pin, shorter once again, all the way. Now, let's go ahead and check the trace here. Just double check. All right, so my negative side of my capacitor right here. And obviously this is ground here. Short's gone. Pin 4, short's gone. Okay. That one pin looks like pin 2. For some reason is reading a short. Alright. That's the current sense. I'm gonna check this little transistor right here. Make sure that's okay. That's not shorted. Nope. It's reading infinite all the way around. Another transistor right here. Good. This little capacitors seem to be okay. Okay. Apply some heatsink compound. Just a little bit. All right. Flip her over. Line. Oh, bad mistake. All right. See if I can line this up right fast. All right, looks good. All right, negative side of my filter capacitor. Number 5 is ground, should be number 5 right here. That's ground, no short. 4, no short, no short. 2 is a short, all right. But I see 2 is actually going to ground through a resistor. This has got to be ground right here, right? Let's see. Yes, the heat sink. What am I looking at here? Here we go. Yeah. Okay. Yes, that is going to ground. All right, so that should be reading ground or low ohms, but everything looks okay. All right, so let's. I don't see anything. It seemed like something would be open because it was a dead set. I was getting the B plus, the 162. But I remember checking these resistors here. The resistance is good. Okay. And I don't see anything else that would open up. Fuse is good. All right, let's see what we get. Okay, guys, so keep our fingers crossed. I'm going to grab my meter again. Once again, making sure I'm on cold ground, which is by the plug here on the cold side, secondary side. Run it right there. Okay, meter's connected. Okay, meters are DC volts. All right, I hope it's going to be this easy, right? And I'm going to plug in my AC power. All right. Don't see any smoke. Okay. And chip's not getting hot. And standby pin 1, pin 3. Let's see what we got here. Pin 3. Whoop, there we go. 5.2. Okay, let me make sure I don't want to slip up here. 5.2 volts standby. That's it, not fluctuate on anything. 5.242. So that was it. All right, and another reason about this board right here is they would trick you, because actually what happened was I bought a repair kit off of eBay, and the only thing they gave me was this capacitor right here. But that capacitor is actually for a problem right here. It's actually for a problem if the set comes on, but you don't have any backlight. All right, and you can usually check it right here. When you turn the TV set on, you can put your meter right here, put it in DC volts, and when you put your lead right here, it's going to start sparking. So that way you know you have backlights then, okay? But if the TV comes on and you put your meter right here and put it in, I'm not sure if it's DC volts or AC volts. I'm not sure. Try both of them and just ground it anywhere on the secondary side. This is in the secondary, I believe. Yes. Yes. If you don't get any voltage there, but the TV is coming on, but you're not getting backlights, the chance is this capacitor right here. But usually it is swollen. All right, so look on the side of the old capacitor, make sure that it is not swollen. All right, but other than that, we are done with this video, guys. Done. Quickest video I did in a long time, right? All right, with that, guys, hey, make sure that you subscribe. Make sure you leave a comment, a question below, and hit the like button, and also hit the notification bell for more videos. And until then, I will see you guys in the next one. Big Dog out. We're done.